Hello children, I am Shubhashish. Children, imagine you're organizing a game day at school and you have 12 friends coming over. You want to arrange them into teams so that each team has the same number of players. If you know about factors and multiples, you can figure out how to divide them into teams easily. Here's how it works. If you want to make sure each team has the same number of players, you need to find the factors of 12. The number 12 can be divided into teams with 1, 2, 3, 4, 6 or even 12 players. For example, you could make one team of 12 players. Two teams of 6 players. Three teams of 4 players. Four teams of 3 players each, or 6 teams of 2 players each. Each arrangement helps you make sure that everyone is included and the teams are evenly split. By understanding factors, you can easily organize your friends into teams without leaving anyone out. In this video, we'll learn how factors and multiples help us organize things in real life, like planning teams for a game day and understanding numbers better. Learning outcomes. After the completion of this lesson, you will be able to know: understand how to organize groups using factors and multiples. Identify prime and composite numbers and their properties. Apply divisibility rules to determine if numbers are divisible by others. Keywords from this lesson are factors, multiples, prime numbers, composite numbers. Divisibility. Even numbers. Odd numbers. Number divisibility. Prime factorization. Children, first let us know about prime numbers. What are prime numbers? A number greater than 1 with exactly 2 factors, that is 1 and the number itself is a prime number. For example, 7 has only 2 factors, 1 and 7 itself. So it is a prime number. However, 6 has 4 factors, 1, 2, 3 and 6. Therefore, it is not a prime number, it is a composite number. Prime numbers list. There are 25 prime numbers from 1 to 100. The complete list of prime numbers from 1 to 100 is given below. Now let us see what are composite numbers. A number that is divisible by a number apart from 1 and the number itself is called a composite number. For example, 4 is a number that is divisible by 1, 2 and 4. Therefore, it is a composite number. Examples of composite numbers: 4, 6, 8, 9 and 10 are the first few composite numbers. Let us take 6 and 8. In the above example, 6 and 8 are called composite numbers because they have more than 2 factors. Let us proceed to understand the important properties of composite numbers. Properties of composite numbers. A composite number is a positive integer that can be formed by multiplying two smaller positive integers. Note the properties of a composite number listed below. All composite numbers are completely divisible by smaller numbers that can be prime or composite. Every composite number is made up of two or more prime numbers. Let us have a look at the properties of the composite number 72 in order to understand the concept in a better way. 72 is equal to 2 into 2 into 2 into 3 into 3. 2 cube into 3 square. This figure shows that by multiplying these positive integers, we get a composite number. Now let us see even and odd numbers. All the multiples of 2 are even numbers. To check whether the number is even or not, we can check the number at ones place. If the number at ones place is 0, 2, 4, 6 and 8, then the number is even number. The numbers which are not even are called odd numbers. Remark: 2 is the smallest even prime number. All the prime numbers except 2 are odd numbers. Test for divisibility of numbers. Divisibility by 2. If there are any of the even numbers, that is 0, 2, 4, 6 and 8 at the end of the digit, then it is divisible by 2. Example: check whether the numbers 63 and 240 are divisible by 2 or not. Solution: the last digit of 63 is 3, that is odd number. So 63 is not divisible by 2. The last digit of 240 is 0, that is even number. So 240 is divisible by 2. Divisibility by 3. A given number will only be divisible by 3 if the total of all the digits of that number is multiple of 3. Example: check whether the numbers 623 and 2400 are divisible by 3 or not. Solution: the sum of the digits of 623, that is 6 plus 2 plus 3, is equal to 11, which is not the multiple of 3. So 623 is not divisible by 3. The sum of the digits of 2400, that is 2 plus 4 plus 0 plus 0 is equal to 6, which is a multiple of 3. So 2400 is divisible by 3. Divisibility by 4. We have to check whether the last two digits of the given number are divisible by 4 or not. If it is divisible by 4, then the whole number will be divisible by 4. Example. Check the number 23436 and 2582 are divisible by 4 or not. Solution. The last two digits of 23436 are 36, which are divisible by 4. So, 23436 are divisible by 4. The last two digits of 2582 are 82, which are not divisible by 4. So, 2582 is not divisible by 4. Divisibility by 5. Any given number will be divisible by 5 if the last digit of that number is 0 or 5. Example. Check whether the numbers 2348 and 6300 are divisible by 5 or not. Solution. The last digit of 2348 is 8, so it is not divisible by 5. The last digit of 6300 is 0, so it is divisible by 5. Divisibility by 6. Any given number will be divisible by 6 if it is divisible by 2 and 3 both. So we should do the divisibility test of 2 and 3 with the number, and if it is divisible by both, then it is divisible by 6 also. Example. Check the number 342341 and 63000 are divisible by 6 or not. Solution. 342341 is not divisible by 2, as the digit at one's place is odd, and is also not divisible by 3. As the sum of the digits, that is 3 plus 4 plus 2 plus 3 plus 4 plus 1 is equal to 70, is also not divisible by 3. Hence, 342341 is not divisible by 6. 63000 is divisible by 2, as the digit at one's place is even and is also divisible by 3, as the sum of its digits, that is 6 plus 3 plus 0 plus 0 plus 0 is equal to 9, is divisible by 3. Hence 63000 is divisible by 6. Divisibility by 7. Any given number will be divisible by 7 if we double the last digit of the number and then subtract the result from the rest of the digits and check whether the remainder is divisible by 7 or not. If there is a large number of digits, then we have to repeat the process until we get the number which could be checked for the divisibility of 7. Example. Check the number 2030 is divisible by 7 or not. Solution. Given number is 2030. Double the last digit. 0 into 2 is equal to 0. Subtract 0 from the remaining number 203, that is 203 minus 0, which is equal to 203. Double the last digit. 3 into 2 is equal to 6. Subtract 6 from the remaining number 20, that is 20 minus 6 equals to 14. The remainder 14 is divisible by 7, hence the number 203 is divisible by 7. Divisibility by 8. We have to check whether the last 3 digits of the given number are divisible by 8 or not. If it is divisible by 8, then the whole number will be divisible by 8. Example: check whether the number 74640 is divisible by 8 or not. Solution: the last 3 digits of the number 74640 is 640. As the number 640 is divisible by 8, hence the number 74640 is also divisible by 8. Divisibility by 9. Any given number will be divisible by 9 if the total of all the digits of that number is divisible by 9. Example: check whether the number 2320 and 6390 are divisible by 9 or not. Solution: the sum of the digits of 2320 is 2 plus 3 plus 2 plus 0 is equal to 7, which is not divisible by 9, so 2320 is not divisible by 9. The sum of the digits of 6390 is 6 plus 3 plus 9 plus 0 is equal to 18, which is divisible by 9, so 6390 is divisible by 9. Divisibility by 10. Any given number will be divisible by 10 if the last digit of that number is 0. Example: check the number 123 and 2630 are divisible by 10 or not. Solution: the ones place digit is 3 in 123, so it is not divisible by 10. The ones place digit is 3 in 123, so it is not divisible by 10. The ones place digit is 0 in 2630, so it is divisible by 10. Some more divisibility rules. Let A and B are two given numbers. If A is divisible by B, then it will be divisible by all the factors of B also. If 24 is divisible by 12, then 24 will be divisible by all the factors of 12. That is 2, 3, 4, 6 also. Let A and B are two co-prime numbers. If C is divisible by A and B, then C will be divisible by the product of A and B, AB also. If 24 is divisible by 2 and 3, which are the co-prime numbers, then 24 will also be divisible by the product of 2 and 3. 2 into 3 is equal to 6. If A and B are divisible by C, then A plus B will also be divisible by C. If 24 and 12 are divisible by 4, then 24 plus 12 is equal to 36, will also be divisible by 4. If A and B are divisible by C, then A minus B will also be divisible by C. If 24 and 12 are divisible by 4, Then 24 minus 12 is equal to 12. It will also be divisible by 4. Points to remember. Whole numbers greater than 1 with exactly two distinct factors, 1 and itself, are prime numbers. Examples include 2, 3 and 5. Natural numbers with more than two factors are composite numbers. Examples include 4, 6 and 8. Composite numbers are divisible by smaller numbers which can be prime or composite. Every composite number can be expressed as a product of two or more prime numbers. Thanks for watching.